Alright guys, so finally, the video you have all been waiting for. I forgot my answer key, so we're gonna hope that I don't get any questions wrong through my process. Um, and I don't have a key to remember what I did, so it's gonna be alright. Okay, so I'm gonna try to go through these questions as fast as possible. If you guys have any questions during class, you guys may ask me to go over any of these questions. All right, so question one. It says, consider the function g and h given by g of x and h of x in the xy plane. What is the x coordinate of the point of intersection of the graphs of g and h? The point of intersection of the functions is pretty much the place where both functions are equal to each other. So to find where the functions intersect, all you gotta do is get the function g and make it equals to the function h. All right, so all I gotta do is find the value of x that makes both of these equations true, to make them the same. The thing is, to make them the same, I need to have them both have the same base. So all I'm gonna do on the right side is I'm gonna make 16 become 4 to the second power. X plus 2. Nothing has changed. Now this 2 will have to be distributed to both the x and the 2. So then this becomes 4 to the x equals 4 raised to the 2x plus 4. Alright, now for both of these things to be the same, both powers need to be the same. That means that x needs to be equals to 2x plus 4. Right? It's just the power of the left side equals to the power on the right side. So there you go. Subtract 2x to both sides. So negative x equals 4. So then x equals negative 4. And the solution is A. Alright, on to question 2. It says the function f is given by f of x, log base 2 of x. What input value in the domain of f yields an output value of 4? So the output value has to be 4. I need whatever the value is for x, I need my solution to be 4. The output value, it's the value that I get in return, has to be 4. So this is my equation. All I gotta do is solve for x. And the thing is, for this one, you don't even have to solve for x. Remember that in a log function, log base b of b to the a power, as long as these two bases are the same, the solution will be whatever the exponent is, right? In this case, would be a. If I want a solution of 4, then this needs to be 2 to the 4th power, right? Because if it's a log base 2, 2 to the 4th power will give me a solution of 4. Given that both bases are the same, my solution will 2 to the 4th will give me 4. Okay, and 2 to the 4th, that's just 16. The thing is, x needs to be 16. The solution is going to be b, of course. Now, you may not know this right off the bat. It's fine. There's a process to solving for this. It's a base 2 logarithm. So what I can do is make both sides become exponents. It's going to be 2 raised to the log base 2 of x equals to 2 raised to the 4th. So both sides became exponents, right? What's going to happen on the left side is that the 2 and the log base 2 will cancel each other out, leaving you with x all by itself. X equals 2 to the 4th. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So 16 is your solution for question 2. All right. On to question number 3. Here we're going to need the unit circle. Okay, so it says the function k is given by k of theta equals 2 sine theta. What are all values of theta for which, and by the way, the values are bounded between 0 and 2 pi. So there will actually be an infinite amount of values, but it just wants the values within the unit circle. It's a keyword here. It wants all the values between 0 and 2 pi. So all the values within the unit circle. For which k of theta is equals to -1. So my k of theta, which is 2 sine theta, needs to give me -1. Okay, k of theta has to be -1. Okay, and k of theta is this. All right, so I want this, which is k of theta, to be equals to -1. Let me solve for sine theta. Okay, let me leave the sine theta by itself. So then this is just sine theta equals -1/2. You are going to need the unit circle right here. Because there are multiple. The thing is, you can also put this, by the way, you can also put this in the calculator. The thing is, if you put it in the calculator, that calculator will only give you one solution. All right, you can see there's going to be multiple solutions right here. So you're going to need the unit circle. Here is where I'm going to be using what I showed you this morning. Well, actually, yeah, what I already showed you. I'm going to draw a unit circle in pretty fast. This is the unit circle. Unfortunately, it's not the pi over 4, the 3 pi over 4, 5 pi over 4, 7 pi over 4 unit circle, because this has 1/2. And remember, it will be a mix of 1/2 and √3/2. Remember also that √3/2 is bigger than 1/2. So yeah, it's going to be that ugly unit circle. So this one, it goes, remember, it goes by sixth. So this one is pi over 6. This one is 2 pi over 6. This one is 3 pi over 6. Alright. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And of course, back here, that would be 12 pi over 6. All right, here to get to this one, the x is the longer. So √3/2, comma 1/2. For this one, it's going to be the same thing as these two, just flipped. 1/2, comma √3/2. For this one, the x is the short. That means x is going to be the -1/2. Because the y is the long, that's going to be positive √3/2. This thing will be the same thing, but this one's backwards. Of course, the x has to be negative. For this one right here, the x is the long one. So x is the √3. And y is the short one. It's the 1/2. Both are going to be negative. For this one, it's going to be the same, just these two but flipped. 1/2 negative, comma negative √3/2. This one, x is the short, positive. Y is the long one, negative, because it goes down. And this one is positive √3/2, comma -1/2. All right, there's my unit circle. All right, so I need sine to be -1/2. All right, sine, I'm looking for the y coordinate. The y coordinate to be -1/2. There you go. This one gives me sine to be -1/2. -1/2 again, another -1/2. Here's another -1/2. This one. So the solutions are going to be 7 pi over 6 and 11 pi over 6. By the way, I think it took me, I don't know how many minutes it took me to make this unit circle. You can check in the video. But these are my solutions: 7 pi over 6 and 11 pi over 6. And the solution is D. D is my solution. Now this is a unit circle that I can use for future problems. We'll see as I continue working through this. Okay, which of the following expressions is equivalent to the, yeah, 4. Which of the following expressions is equivalent to log base 3 of x to the 5th? Easy, easy peasy. Log base 3 of x to the 5th. Remember, I can bring the power, bring it to the front. So this becomes 5 log base 3 of x. And my solution is C. That's question 4. Right. Let's go to question 5 now. Which of the following statements is true about the exponential function h, given by h of x equals negative 3 x to the 4th? It's an exponential function. This thing is an exponential function. All you gotta know is that the regular exponential function looks like this. That's an exponential function. All right. The thing about this exponential function is that the a, the first value there, is negative. If that a is negative, because remember, all exponential functions, well, these exponential functions can be expressed as a times b raised to the x. Okay. The thing is, if a is negative, then you get the same function, right? But reflected across the x-axis. So because this thing is negative 3, my function is going to look like this. Okay. It may not look perfect, but it's going to be going down like that. Right? So it's not this one, because that would be if that was a positive 3. Okay, the thing is this thing is negative 3, okay? So it's going to be going down like this. Alright. Okay, so this thing, it says increasing, decreasing. It's always, the thing is, this thing is going down. This thing is always going down. It's decreasing always. It's always decreasing. Alright. And h always concave down. Concave. This thing is concave down, guys. Concave down. Okay, this thing is concave down. Okay. Yeah, because on this side, it's the thing. It's close to this horizontal asymptote at 0. All right. It's very close right here. Okay. But as you continue, of course, you're getting farther and farther away. As you go to the right, you're getting farther and farther away from that horizontal asymptote. So this thing is coming down. It's decreasing, and it's going to be concave down forever. So it's decreasing and is concave down. D is your answer. Question 5. Question 6. I'm not going to spend a lot of time working on this one. Okay. I'm going to summarize this one to 2 solutions. And then during class, we can analyze it a little more. All right. The one way that I can summarize this to 2 solutions, it's that the function tells you that it has a hole at 2, at x equals 2. The function f of x is going to have a hole at x equals 2 if you get x minus 2 to be a factor on both top and the bottom. Alright. The thing is, this is going to become a hole because it'll get cancelled out with x minus 2 on top. Alright. That's why it becomes a hole. So this brings us to pretty much the solution being either A or B. Alright, because both of them have x minus 2 on top, x minus 2 on top and bottom. Alright, I'm going to talk about, we can talk about this one later during class. I don't want to spend a long time working on question 6, because I know it takes a long time to explain it. Question 7. This question is more of like just making sense of the shapes. At time t equals 0, okay, at the beginning, water begins pouring into an empty container at a constant rate. The water pours into the container until it is full. The situation is modeled by the given graph, this graph, where time in seconds is the independent variable and the depth of the water in the container in centimeters is the dependent variable. The thing is independent variable, okay, that's just your x. That's the x-axis. And then the dependent variable, that's just the y-axis, okay? The thing is, the values of y depend on whatever value of x you have. So that's why the y is the dependent and the x is the independent. For which of the following containers would the graph be appropriate? I like to take a look at the middle of this graph, okay? Take a look at what happens for like from here to here. If you guys notice right here, the graph is very steep. because the graph is very steep right here, it means that it's going fast. The steepness of the graph pretty much tells you how fast something is going. All right, and if you guys see on this center, like in the middle, the graph is very steep. It's growing pretty fast. Okay, so it means that the container is getting filled up faster in the middle. All right, it will definitely not be A, because the graph for this one would look like a straight line, because the it'll be constant throughout the time that it will take to get filled up. Okay. If we look at C, we notice that in the middle, okay, as water starts like filling up and you get to the middle, it's actually gonna take longer to fill this whole area of water. It's gonna take longer right here. This area right here, filling up the container, is gonna take me longer. Okay, so it's definitely not this one, because in the middle, the container should actually be getting filled up faster. And same situation with D. In the middle, you can see it's gonna take me longer to fill this middle section right here of water. Okay, so not this one as well. This one makes more sense, as you can see in the middle right here, because it's very thin. The water is going to be the height of the water as it's being poured into the container is going to be increasing very fast. Okay, and then as you go higher, okay, the height of the water in the container will actually be increasing slower and slower. B is the solution for question 7. Let's go to question 8. At time t equals 0, the population of a certain city was this. If I start getting values, okay, time and the city, this is population. Let me use P. It's not giving me an actual name for the function. Let me use P for population. Okay, at time 0, I get a population of 23,144 people. During each of the next 10 years, the population decreased by 4% per year. Okay, so after a year, no, after 10 years, during each of the next 10 years. Okay, no, like the next year, okay, throughout the next 10 years, each year the population will decrease 4%. Okay, so the next year, the next value that I should have right here should be 4% less than this. That's a horrible way of thinking of this percentage. I'm not going to say 4% less of this. Actually, after year 1, I'm going to be left of, I'm not going to say 4% less. Instead, after year 1, I'm going to be left with 94% of the population from the previous year. Okay, so to calculate how many people I have right here, all I need to do is calculate 23,144 times 0.96. 0.96, all right? That way, I don't have to, because the thing is, if I calculate 4%, then I need to take that 4%, subtract it from this, and then that'll be the population after a year. It's easier for me to calculate 96%. That's how much the population is going to be. I brought a calculator that I can use. So let's see. It's going to be 23,144 times 0.96. I'm going to be left with this population a year after. That is 22,218.24. That's my population after a year. All right. The next year, guess what I need to do? I need to take this value, okay? Just click, by the way, just click on multiply, and it'll take the answer that you got previously. It's taking ANS, stands for answer. It's taking this answer, multiply by 0.96. All right, this way I'm calculating 96% of this, which that'll be the population the year after. It's going to be 21,329.5104. The year after, multiply by 0.96. And that gives me the population the year after. Guys, you guys don't have to do this. I'm just trying to explain something that's happening right here. The thing is, to get to the next number, I multiply by 0.96. To get to the next one, I multiply by 0.96. To get to the next one, I multiply by 0.96. Okay, get this pattern. All right, this thing is going to be 0.96 raised to the t power, raised to the time. I guess you guys can already see what the answer is going to be. You guys can already see that the answer is going to be C. You guys don't even have to do anymore. All right, but remember, this is an exponential function. It's of the form a b raised to the x. Okay, well, remember, a is the initial value, which in this case it's going to be 23,144. That's why we have it there. Okay, and b represents the ratio, the common ratio, the number that we multiply again and again and again. That is your common ratio. Okay, that's your common ratio. That's why it's that one is the one that has to be raised to the power. And that's it. Question 8. Question 9. This question. That's so nice. I love these questions. By the way, secant squared x minus 1. If you guys see secant squared x, tangent squared x, sine squared x, cosine squared x, most likely it's going to be some type of Pythagorean identity. Okay, that, by the way, you don't have to memorize all of them. The one that I do memorize is the sine squared x plus cosine squared x equals 1. Okay, now there's 3 Pythagorean identities. I need the one that has secant as an identity. Okay, and secant, remember, secant is just 1 divided by cosine. So I'm going to divide it by cosine squared x. Everything. Right? This is going to be sine divided by cosine squared x. Sine divided by cosine, that's tangent squared x. Cosine squared x divided by cosine squared x, that's just 1. And 1 divided by cosine squared x, that's just secant squared x. How do you see? If I subtract 1, it'll be secant minus 1, secant squared x minus 1. And that's tangent. Okay? So tangent s squared x equals to secant squared x minus 1. Look at that. So this thing, the numerator at the top, is just equals to tangent squared x. Okay? Alright, so then this thing becomes tangent squared x divided by secant squared x. Okay, I'm gonna make everything into just sine and cosine. Everything just into sine and cosine. Alright, so tangent squared x is going to become sine squared x divided by cosine squared x. And the denominator is going to become 1 divided by cosine squared x. Alright, got fraction over a fraction. Keep, change, flip. So keep the first fraction, sine squared x divided by cosine squared x. Keep, change the division to multiplication and flip the bottom fraction. It'll be cosine squared x over 1. Guess what's going to happen to cosine squared x? 1 cosine squared x is on the top, a cosine squared x on the bottom. This whole thing simplifies to sine squared of x. My solution is C. And that's that one. That's question 9. Alright, okie dokie. So, question 9, done. Let's go on to question 10. Where's question 10? Here's question 10. Alright. The location of point X in polar coordinates is... here we go. Which of the following describes the location of point X in rectangular coordinates? Rectangular coordinates, guys. Remember, X is radius, cosine, theta, comma, radius, sine, theta. That's it. Okay, the radius is 1. So my coordinate, the first coordinate is going to be cosine of theta being 5 pi over 6, comma, and again 1 sine 5 pi over 6. If you guys notice right here, finding these ones, you don't even need a calculator. Alright, oh, by the way, I'm sorry, this one, this say no calculator allowed. And I just used it for the previous problem. But I used it more to let's explain how to do it. Okay, it doesn't matter. Alright, this one. You don't need a calculator to do this. It's 5 pi over 6. Guys, you guys can find that in the unit circle. Where's my unit circle? Where did I did it? Right here. Cosine 5 pi over 6. Let's find 5 pi over 6. 5 pi over 6. Here's 5 pi over 6. And cosine, that's the x, that's negative root 3 over 2. And sine at 5 pi over 6 is 1/2. Oh, look at this. The solution is A. A is my solution. Question 11. It says in the figure, the figure shows the graph of an exponential function, decay function f. Exponential decay. It's an exponential function. Okay, don't think too much about it. It's an exponential function. It's an f of x. Is going to be some a raised to the b. It's that times b raised to some x power. It's an exponential function. The coordinates of two of the points are labeled. Okay. Well, yeah, nice. It's giving me 2 points. If it gives me 2 points, it's gonna give me two equations. If I get 2 points, I can make 2 equations using each point. The coordinates of 2 points are labeled. Okay, what is the y coordinate of the point on the graph where x equals 0? It's asking me for, like, when x is 0, what's the y value? What's the y coordinate? When x is 0, what's the it's asking me to find this point, the coordinates of this point. Okay, I know x is 0. The question is what is the y value? What's the y value? All right, well, let's see. I need to make up the equation. I need to find a, I need to find b. Easy. All right. The first equation. When x is 2, ab to the x, sorry, ab to the second, because x is 2, is equals to 10. Then when x is 3, f of 3, okay, ab to the third, it's equals to 5. All right, these are my 2 equations. All right, remember, I'm going to use one equation to leave one variable by itself and then plug it into the other equation. All right, so let me take the first equation, and so ab squared equals 10. And let me leave a by itself. So let me divide both sides by b squared. So on the left side, that goes away. So then a equals 10 divided by b squared. The thing is, yeah, there we go. This thing is a. This thing is a. I'm going to take this a, and I'm going to plug it into the other equation, which is this one on the bottom. Okay. So then instead of writing a, I'm going to write 10 over b squared. Okay, that's my a. And then that times b cubed equals 5. All right, so I took the a that I got from the first equation. There's my a. I plugged it into the second equation. So now instead of a, I wrote 10 divided by b squared times b cubed equals 5. And the thing is, b squared and b cubed, there's going to be 2 b's on the bottom that will get cancelled out with 2 b's on top, leaving me just with b, just plain b. So this, well, times 10, right? 10b equals 5. That means b is going to be equals to 1/2. There you go. That's my b value. I got b. All right. Once I have b, I have options. Now I can take this b and I can plug it into this one, which is going to be the best option, by the way. I could also plug it into this one, any function that has b in it. Okay, this is the best one because a is already by itself. If I plug it into this one, sure, I can plug it in. I would have to cube b and then divide both sides by that. Actually, using the top one will be easier. It doesn't matter which one. You can plug it into this one, or this one. Because I'm a mathematician and I kind of can predict the future here, I know that plugging it into this one will be actually easier to the top one. It's going to be a times 1/2 squared equals 10. This whole thing becomes, well, 1 squared is just 1, right? And then 2 squared is 4 equals 10. This thing becomes a over 4 equals 10. And then to leave a by itself, multiply 4 on both sides. So then a equals 40. A equals 40. That's it. I have everything to now build my equation. My equation has been built to be f of x equals a is 40. The initial value is 40. The common ratio is 1/2 x. This is the equation. This is the formula. This is the function that makes this graph. Okay. The question is, when x is 0, what's the y value? That's been the question. When x is 0, what is this thing equals to? This becomes 40 times 1/2 raised to the 0 power. Anything to the 0 is just 1. This thing is 40 times 1, which is just 40. The answer is A. Okay. There you go. That's question 11. All right, moving on. This one was lengthy. This one took me a while, but I explained it. So there you go. This one, it says the table gives values for a function g at selected values of x. Which of the following statements is true? Linear, quadratic, linear. Oh, okay. Okay, if a function is asking you, is it linear, is it quadratic, is it exponential, there's specific patterns that you want to look for. An exponential function, there will be a value that keeps multiplying to get you to the next number. It's like the table that I did for which question? For this one. Okay, this would be an exponential function. Gets to get from here this one to this one, you multiply to get to this one to this one, multiply by a common value. All right, that will give you an exponential function. A linear function will add some value repetitively to get to the next one and the next one and the next one. That would be like something like +5 will give you this one, +5 will give you the next one, +5 will give you the next one. Okay, then you have quadratic functions. For quadratic functions, the thing is you have to find a kind of like a second pattern. So the first pattern will be what do you do to get to this one to this one? You can see that we are -3 to get to -2. This adds 1. All right, then to this one you add what, 3? 3. And to this one you add 5. From this one to this one you add 7. Okay. So this is not a familiar pattern, right? This doesn't look familiar at all. But you need to find a second pattern. If the second pattern works out to have a common difference, then the function would actually be quadratic. All right, from this one to this one you add 2. From this one to this one you add 2. From this one to this one you add 2. Okay, when the second pattern is a common difference, all right, this could be adding, could be subtracting. Okay, when the second pattern gives you a common difference, then the function is going to be quadratic. Okay, so that leaves us with two options. The function is going to be quadratic or quadratic. It's not going to be C or A. Okay, G is modeled by a quadratic function because the average rates of change over consecutive equal length, but values are constant. No, is modeled by because the successive second differences. Okay, that's the second differences. Actually, that's the whole explanation I just made. The second differences. Okay, sure. This is the first differences. This is the second differences. Over equal interval values are constant. So yeah, the differences right here is constant. It's always 2. The solution is D. Alright. Kind of got tired now. It's alright. I'm doing it for you guys. Question 13. The function f is given by f of t equals e raised to the t. And the function g is given by g of t equals 7 ln of t. The function h is given by h of t equals f of g of t. Which of the following is an expression for h of t? Okay, it's asking me to find h of t. That's it. It's a composition of functions. You've got h of t. Now I don't like this notation. I like to rewrite it as f of g of t. Okay, which means it's going to be the function f. Okay, it's going to be my function f in terms of g of t. So whatever g of t is, I need whatever g of t is, this thing, I'm going to replace all t's on my function f by this thing. Okay? It'll be e to the t, but instead of t, because instead of t, you straight see, instead of t, I have g of t. Okay? So my function f, instead of having just t, is going to have g of t. So this t will become 7 ln of t. Híjole, but that doesn't look like any of these. No worries, no worries. Be happy. The thing is right here. This thing, this 7 right here. Remember, rules of logarithms. If you got a log, ln, or log, whatever it is, of x raised to some a power, that power you can bring it to the front and make it a ln of x. And vice versa, you can take this one and bring it to the top, and it'll reverse back to this one. So you see the 7, I'm going to bring it to the top, making this ln of t to the 7th. And then remember, e is the same base as ln. Remember, ln is just log base e. With e and ln will cancel each other out. So then h of t becomes t to the 7th, because the e and the ln will cancel each other out. This whole thing becomes t to the 7th power. B is your answer. 14. Skip 14. I don't want to do 14. It's not going to be in the test. Okay, maybe it'll be in the test. I don't know. 14, 15. Oh my goodness. These functions, guys. It's a function of cosine. It has no phase shift. Okay, there's no phase shift. It's cosine. It will definitely not be this one, because cosine, remember, cosine begins on the top. Cosine begins at a maximum value. This thing begins on the midline. This thing is a function of sine. Okay, this one does begin on top. This one does begin on top. This one does. All of these are cosine. All right, now I need a midline at 1. The midline must be at 1. If you notice this one, the midline, the line that cuts this thing in half, is at 2. Right here, the midline is at 2. The midline is at 1. Okay, remember that? That's the midline. That's D. D has to be 1. This right here, I get D to be 2. Okay, so that's not it. Okay, this one, let's see, the midline. Oh, this one, the midline is actually at 1. Okay, this one, this is a good candidate. Okay, this one right here, the midline is also at 1. Okay, so for both of these, D is correct. D is on point. Now I need an amplitude. Remember, this is the amplitude. The 2 is the amplitude. The amplitude from here to here, that's 2. Okay, that's definitely the good amplitude. And that's also 2. Okay, both of them have a good amplitude. Both of them have a good midline. Okay, now I gotta check the period. Remember, this thing is not the period. This thing is B. B helps you find the period. And remember that the period of a sine or a cosine function, not the tangent function, but for sine and cosine, which is what we have, the period is equals to 2 pi divided by b, which in this case is pi, which the period should be 2. Which one has a period of 2? Well, to find the period, it's very easy. All you gotta measure the distance from one top to another top. That distance is gonna be the period. So the period of this function is 4. That's not it. If you notice, what's the distance between this top and this top? It's 2, which is the period that I want. The answer is A. All right. 16. All right. It says the figure shows the graph of a function g in xy plane with 4 labeled points. It is known that a relative maximum of g occurs at A. Sure, A is a maximum. Definitely. And the only point of inflection of the graph of g is C. Okay, C is a point of inflection. Of the following points, at which is the rate of change g least? Okay, now remember, if you get a negative rate of change, that's smaller than a positive rate of change. Keep that in mind. A negative rate of change is smaller than a positive rate of change because it's negative. All right. Don't go based off of steepness. Okay, because the thing is, right here, the steepness at A, I have the average rate of change at A is going to be a tangent line. Okay, and it's going to be a slope of 0. Right here, my average rate of change, my slope is 0. All right. If you look at D right here, the slope is going to look like this. It's going to be at a tangent. All of these slopes are calculated kind of like at a tangent. Okay. Remember, the tangent will just touch that point at that particular point. The slope of D is right here. I don't know what it is, but the slope is going to be positive, some positive slope. All right, some positive slope. Now, if you notice right here, the slope is actually negative. The slope is negative. It kind of like goes through it like this. It is negative. So right here, this C is pretty low. It's pretty negative. And then at B is also negative. Okay, the question right here you guys should be asking, which one is steeper? Which one has a steeper angle? C or B? The thing is, if you guys notice, the closer you're getting to A, the less steep the angle becomes. The closer you get to A, the less steep the angle becomes. All right. So the thing is, the steeper angle right here, it's C, and not only is steeper, it's also negative. So the question is, of the following, which rate of change of G is the least? That's going to be C. Okay, because it's the steepest. Sure, it's the steepest. You may be like, what? That's the steepest. Okay, a lot of you guys will think actually that it's A because it's like it's 0. It's not steep at all, right? The thing is, you gotta be careful because a negative rate of change will actually be smaller than a positive rate of change. In this case, we're looking for the steepest, but that's negative. Okay, in this case, it's gonna be C. Okay, C will be the steepest rate of change because it's, well, not the steepest, it's going to be the smallest because it'll be a bigger negative. 16. 17. I don't like this thing. The table gives polar coordinates. Okay, gives you R, gives you theta. For 4 selected points, which of the points lies in quadrant 2? Why? A, because from the positive y-axis, pi over 4 counterclockwise is in quadrant 2. Guys, I don't know how to do this one. Maybe. Actually, no, I do. It's okay. It's giving me 4 points, right? It's giving me 4, and technically these are coordinates, okay? These are coordinates in polar coordinates. That's it. All right, now the thing is, if the radius is positive, I'm gonna go this way. Okay, this is gonna be positive radius. Okay, positive radius. If I go to the left, that's just going to be negative radius. All right, now remember, if I go clockwise, going positive, that's going this way, and going negative, it's going down. Okay, so for this one, I have to go to the right 2, and then pi over 4 down. Right there. That's the first one. It's going to be at a radius 2 right there, and going and traveling negative pi over 4. There it is. And this is quadrant 4. Quadrant 4. All right. It says, which one is in quadrant 2? Okay, so it's not A. 2. 2 is going to be, again, 2 over. And this time we're going to go 3 pi over 4 units. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Again, with a radius of 2, 1, 2, okay, the angle will travel all the way around to pi over 4. The thing is, this is quadrant 3. So not that one. The second one is negative 2. Okay, negative 2 right there. Okay, and right here at 2, at negative 2, I need to go clockwise now. Now I'm going to go clockwise. It's going to be 5 pi over 4. So this is pi over 4. Like a quarter of a quadrant is pi over 4. Okay, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. and I land on top of this one again. So from here, going 5 pi over 4 will take me back to this one, okay? So it's also not gonna be C. Okay, it's gotta be this one. It's gotta be this one. Okay, let's see again. Starting at -2, I need to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. What did I do? 1, 2, 3, 4, 5, 6, 7. Oh, my bad. Guys, I was going clockwise. It's positive. Positive goes this way. Don't make that mistake. Use me to learn from my mistakes. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. It's right here. Quadrant 2. Ha. I thought I was gonna get stuck. No. The answer is D. And I don't know, maybe I did C wrong. Let's see. At -2, I need to go this way. Okay. That was my mistake. I went this way. Okay, I need to go counterclockwise. Positive is counterclockwise. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 would be right here. This one would be positive 5 pi over 4. Okay? Starting at -2. Okay, starting at -2, 7 pi over 4 gives me the right answer. 17. Let's go to 18. The amount of water used each day in an office building measured in hundreds of gallons is modeled by the function g defined by g of t equals that. Okay. For integer values of t, with 0 to 365 days. Using actual data over time, it was determined that the model underestimates the amount of water used each day by 800 gallons. Based on this information, which of the following function is better modeled? It's a better model for the amount of water used each day measured in hundreds of gallons. Okay, so the thing is about this problem is that this thing gives you the measurement of the water. The thing is that for every t is the days, right? T represents the days. The thing is every 1 day that we calculate, my solution is always below 800 gallons. Okay, it underestimates the value by 800 gallons. Okay, so the solution right here would be to adjust this function so that instead that it will always underestimate the solution by 800 gallons. It would be great if I could add 800 gallons add 800 to this, so that the whole thing will balance out. Okay, so by adding 800 to my solution every time, that will not underestimate the amount of water used each day. Okay, so what I have to do is I have to add 800 gallons. The thing is, you guys may be like, well, none of these are adding 100 gallons. The thing is that right here, 1 unit represents 100 gallons. Okay, to adjust this so that to adjust it so that the solution represents an additional 800 gallons, I need to add 8. Okay, so because the thing is, if you calculate, let's say at 7 days, and you get a solution of 40 or like 7, okay, that's just that 7 will stand for 700 gallons. All right, so if I add 8 to my function, that will fix it. That's B. Okay, it's 25 plus 8. That'll give you the 33 that you need. Okay, adding 8 to the whole thing, will make my solutions be balanced out. It will not be underestimating 800 gallons anymore. So B is the answer. Question 19. In the xy plane, two different angles, alpha and beta, are in standard position and share a terminal ray. Based on this information, which of the following gives possible values for uh, alpha and beta? Okay, so I have an angle. Okay, where are these angles? Have no idea. The thing is that these angles, well, and actually let me make a general picture. Okay, let's say that's my angle alpha. Okay, that's my angle alpha. Okay, now the thing is, these are two different angles. They're not the same. They both are in standard position, which means they both begin right here. They both began at 0. Okay, and from here alpha opened up and got there. This is my terminal ray of alpha. This is where alpha ends. All of these, both alpha and beta, begin right here. Well, alpha ends right here. The thing is, beta will also end right here. Beta will also end right there on the same spot. Both of these terminal rays for both alpha and beta will be on the same spot. The thing is, this one is for alpha, right? This angle right here represents alpha. The thing is, beta needs to also end here, but it could not be the same thing as sorry, beta also has to end here, but it cannot be the same thing as alpha. The thing about beta is the beta is going to go that distance in addition to another 360 degrees, or in addition to another 2 pi radian, or not even 2 pi. It could actually go around more than twice. 1, 2. It could even go 4 pi additional degrees around. Okay, so how am I going to find my solution right here? The thing is, this thing, to get from here, if I add or subtract 2 pi to this, it needs to give me that. From here to here, if I add or subtract 2 pi to this, it needs to give me this. If I add or subtract 2 pi to this, it needs to give me this. If I add or subtract 2 pi to this, it needs to give me this. Okay, because in order for me to get back to the same thing, I need to add 2 pi or subtract 2 pi, or add 2 pi, 4 pi, or 6 pi, or 8 pi. Okay, so I gotta find out which one of these adds or subtracts 2 pi or 4 pi, perhaps. Okay, how do you find this? Subtract them. Okay, how do you find their difference? All you gotta do is subtract them. It doesn't matter in which way you do this thing. Okay, you see this negative 4 pi. Take negative 4 pi. Sorry, negative pi over 4. Sorry. And you see this negative 7 pi. You want to add it to this one, okay? But you're going to have to change the sign of this one. And that will be plus 7 pi over 4. And right here I get 6 pi over 4. And this thing doesn't simplify to 2 pi or to 4 pi or to negative 2 pi. Okay, that's not the answer. Let's take the next one, 3 pi over 5. Keep that one the way it is. This one is negative. Well, switch its sign. Make it positive. 3 pi over 5. This will give me 6 pi over 5. It doesn't simplify to 2 pi. It's not the answer. Take the next one, 2 pi over 3. And this one is positive. Now I'm going to change its sign. It'll become negative. This becomes negative 6 pi over 3, which simplifies to negative 2 pi. There you go. Now, does the order matter? No. The thing is, you could have actually kept the 8 pi over 3 the same. Don't switch the sign of this one. And actually switch the sign of the first one, minus 2 pi over 3. That will give you positive 6 pi over 3. Now, it doesn't matter if the solution is positive or negative. As long as you're either adding 2 pi or subtracting 2 pi, it means that from this angle, you added 2 pi, exactly 2 pi, to get to this one. Okay? Or from this angle, you subtracted 2 pi to get back to this one. Okay? It means you did a full cycle to come back to the same terminal angle. C is my solution. Okay, this one would actually change the sign. It becomes 1 pi over 6. Code becomes 6 pi over 6. It would simplify to pi. C is the answer. 20. In the xy plane, the function h given by h of x equals this. It's a horizontal translation of the exponential function f given by f of x equals 3 to the x. Which of the following is equivalent? It's an equivalent form of h of x that expresses h as a vertical dilation. Vertical dilation. Okay, it just means that vertically the graph is either getting larger, like it's stretching, or compressing. Okay, I need a vertical dilation. Okay, thing about a vertical dilation. Okay, if you can have either a vertical dilation, okay, or a horizontal dilation. This one is the easy one to identify. The horizontal one is the easy one to identify, because for a horizontal dilation, let's say you have the same function, right? Let's say you have 3 to the x. Okay, the thing is, in order to make this thing have a horizontal dilation, you need to either multiply or divide by the x value. So if I multiply the x by 7, okay, right here, I'm only affecting the x value. That means I'm affecting the horizontal values. Okay, if I multiply only the x by 7, this will be a horizontal dilation. Okay, now to affect the function vertically and get a vertical dilation, okay, the thing is this whole thing represents y. The whole thing represents y. So to express a vertical dilation, what you would have to do is you would have to multiply the whole thing by some number. So you see, right here, 3x, actually, the whole thing, the whole 3x represents y. If I multiply the whole thing by 7, technically I'm affecting, right there I'm affecting the solutions, the y values. Okay? Versus this one, if I only multiply to the x values, okay, take all the x's and multiply all the x's by some number, that will affect the function horizontally, but not vertically. Okay? It will make the function get like fatter or skinnier, if depending on what the number that you multiply to the x's. So right here, I'm looking for not this one, not D, because D is adding. I'm not adding. It's either multiplying or dividing. Okay, not this one, because you see this one, I'm affecting the x value. I'm dividing the x by 2. Okay, so not this one. This would be horizontal. Okay, it's going to be either this one or this one. But the thing is, the original function is 3. The original function is 3. This thing did like 2. Sure, it multiplied by 9. Yes, but then it changed this. Okay, that's a whole different function. This will be a whole different function. So it's not this one. The solution you want is B. All you want is a vertical dilation. So you need to multiply 9. You need to multiply something to the original function. Okay, so multiplying by 9 and doing something to the whole thing. And then the whole thing represents, this whole thing represents the y value. So if I multiply the whole thing by 9, I'm affecting the y values. Vertical dilation. The y values. Because the y values are vertically. Question 21. My legs. I'm old. The table gives values for a polynomial function g at selected values of x. I don't know if I want to skip this one. Well, let's see. Let's try it out. I know when you can see a lot of reading, you just want to skip it. I'm the same, but you just sometimes I would skip it. Okay, I would skip it and go on to the questions that don't have maybe a lot of writing, and you can like just do them. Okay, the table gives, but I should know how to do it. Maybe the table gives values for a polynomial function g at selected values of x. If a is less than b, then g of a is bigger than g of b for all values for all a and b in the interval 3 to 7. 3 to 7. Which of the following could be true about the graph of g on the interval 3 to 7? Okay, the graph of g is concave down, a concavity thing. Okay, guys, this is going to be, we're analyzing a graph. I would say if it's talking about concavity and everything, it's talking about a graph. Okay, we can just try, attempt to draw the graph. All right, attempt to draw it. Okay, at 3, right there at 3, I go down negative 11. Ooh, wait a minute. It's also asking me about the average rate of change. I need to know what the average rate of change is right here. By the way, because the thing is, my graph, because the values are decreasing. As you go over, the values are decreasing. The thing is, the values can decrease this way, which would be concave down, right? The values are decreasing every time. And that would make sense. The thing is, if you guys look at this one, the values are also decreasing every time. But this one is concave up, and this one is concave down. So this is where we go back to unit 1. And guys, right now I have to kind of like try to remember what we learned in unit 1. Do try to remember this. Concave down and concave up, right? This is concave down, concave up. Okay, right here the slope is positive, and as you go over, the slope is getting smaller and smaller, and then getting even smaller and smaller because it becomes negative. So right here the slope for concave down decreases, always decreases. Okay, and by slope I also mean the average rate of change also goes down. Okay, from left to right, the slope will always be decreasing. And it's the opposite for this one, because you see from left to right, this one is negative slope. It becomes a smaller negative, it becomes 0, and then it becomes positive. So this one, the slope, is actually going up. And not only that, again by slope, I also mean the average rate of change. So all I gotta do right here to find out whether the graph is concave up or concave down is check what's going on to the average rate of change. All I gotta do is compare the average rate of change. Okay, it says the graph is concave down because the function is decreasing. Okay, so yeah, the function will always be decreasing. Okay, that's a given. It'll be decreasing. Okay, it doesn't mean that it's concave up or that it means concave down. Decreasing has nothing to do with that. It's the average rate of change. Okay, I need the average. If the average rate of change is decreasing, and it's going to be concave down. If the average rate of change is going up, then it's going to be concave up. I gotta find out the average rate of change. All right. So to do that, remember the average rate of change is the x1 minus the x2 divided by my g of x1 minus g of x2. I don't have to calculate these values because they're already given right here. So like my average rate of change from here to here is going to be 3 minus 4 divided by negative 11 plus 19. That's the average rate of change from here to here, which gives me negative 1 over, what, 8? 8. All right, what about the average rate of change from 4 to 5? From 4 to 5, that's going to be 4 minus 5 over negative 19 plus 29. That's going to be what? Negative 1 over, what is this, 10? 10, yeah, 10. You guys can see, if the number on the bottom is small, then it's a big number. If the number on the bottom gets bigger, then it's a smaller number. So this thing from here to here actually became a, how do you call it? From here to here, it became smaller. But because it's negative, it actually became bigger. You gotta be careful with that. The bigger a negative is, the smaller it actually is. Okay, because it's negative. Okay, let's try the one from 6 to 5. That's gonna be 5 minus 6 over negative 29 plus 41. That's going to be negative 1 over, what is that? what is 29? It's gonna be 12. 12 positive. Yeah. Okay, so the denominator is getting bigger, which means the number is getting smaller, but it's negative, which means it's getting it's getting bigger. Okay, yeah, you can put these in a timeline, put them in a timeline, right? Okay, the thing is, the farther to the right you are, the bigger the value is. Okay, so right here, negative 1/8, let's say negative 1/8 is right here, negative 1 over 8. Okay, negative 1/10, that's actually farther this way. Negative 1/10 is right here. But you see, it's getting actually bigger. Negative 1 over 12. Negative 1 over 12. It's okay. It's getting bigger. It's getting bigger. Okay. Maybe you guys don't believe me. Maybe you guys are like, ah, what's he talking about? 1 divided by 8 is this. This one will be getting closer to 0. Should be getting closer. The closer to 0 work because you see all of these values, for them to become positive, they need to be getting closer and closer to 0. So let's see. 1 divided by 10. 1 divided by 10. It's gonna be to 0.1. Okay, you see 0.1, but it's actually getting closer this way. All right, let's see 1 divided by 12. 1 divided by 12, that gives me 0.08. That's even closer to 0. Okay, you guys can already predict what's going to be the next one. It's going to be 1 divided by 14, maybe. 1 divided by 14. Look at that. It's getting closer and closer. The thing is getting closer this way. It's getting bigger. Okay, it's going to be analytic. Okay, it's going to try this thing out. Okay, this thing is going to, my rate of change is increasing. This thing is concave up. It's concave up, it's concave up, because the function is decreasing. Yes, the function is decreasing, and the average rate of change, or the intervals, the average rate of change is increasing. Okay, not this one, because the average for the concave up, it's the average rate of change doesn't decrease. Concave up, the average rate of change increases. By the way, this question could have been a question that you could have just memorized. Okay, the thing is, all you gotta know right here is concave up, the average rate of change increases. And well, no, actually, you did have to analyze the thing. It seems like, okay, yeah, no, forget what I just said. Yeah, you do have to analyze this thing to see how the average rate of change is behaving. All right. 21. 22. We've got this thing. So it says the function g, this one's easy. The function f is given by f of x equals 2 cosine pi x plus 3. The graph of f is mapped to the graph of g. Okay, so we're taking the function f and then we are mapping one of these, the right answer, right? So by mapping, it just means taking this and transforming it into something else. All right, the graph of f is mapped to the graph of g in the same xy plane by horizontal translation. Horizontal translation, guys. The moment we've been waiting for. A horizontal translation, guys. This is a phase shift. Remember, a cosine b times x minus c plus d. That's a it's gonna be something like, you guys can already see it's gonna be either a or b. It's a horizontal translation. Okay, you can see C and D. They have no horizontal translation. Actually, the horizontal translation of the graph of f by pi over 2 units to the right. Okay, this thing it's got to go to the right. Pi over 2 units. You see this pi over 2 that they subtracted right here? That's making the graph go down. That's not a horizontal translation. Right here they added pi over 2. That's making the graph go up pi over 2. That's not a horizontal translation. None of those are the answer. Okay, now to make the function go pi over 2 units to the right, c needs to be negative pi over 2. The answer is B. By the way, a possible, yeah, maybe. Now let me leave it like that. The answer is B. Okay. It's gonna be negative because remember, Negative makes it go to the right, positive makes it go to the left. Okay, so to right here, C would have to be negative pi over 2. Okay, it has to be this one. Negative pi over 2, this thing is going to make it go to the right because this thing is negative. Inside of the parentheses, a horizontal shift. If it's negative, it goes to the right. If it's positive, it goes to the left. The answer is B, 22. Question 23. I skipped this one. I don't know how to do this one. I don't even want to do it. 24. These questions. Let's see. The figure shows a circle centered at the origin with an angle measured theta degrees, theta radians in standard position, and point P on the circle. Point P, okay. On the circle, the terminal rate of the angle intersects the circle at point Q. Okay, there's point Q, sure. The length of arc PQ is 6 units. Okay, the length of the arc is 6 units. So the length of this arc is going to be 6 units. Which of the following gives the distance of point Q from the y-axis? From the y-axis? Let me read that again. Which of the following gives the distance of point Q from the y? It's asking me to find this. It's asking me the distance of point Q from the y-axis. It's asking me to find this distance right here, or this distance. It's the same distance. It's asking me for the x value. For the x value right here. Guys, I don't know how to do this one. Point P, it's right there, sure. I would want to use. Okay. If I use cosine would have to be cosine is what is cosine? Is adjacent over hypotenuse. Adjacent is okay. Cosine is adjacent over the hypotenuse, and the hypotenuse has to be 5. Okay, all of these have 5 on the bottom, and the adjacent. But the adjacent is not 6. Guys, I don't know how to do 24. We'll analyze it and do it during class. 24. Enigmas of mathematics. 25. In the xy plane, the graph of which of the following functions has a vertical asymptote that x equals 3 pi over 4. So in the xy plane, the graph of which of the following functions has a vertical asymptote that? Okay, this one looks, it's weird. Okay, cotangent. Okay, I have cotangent of something. The thing about cotangent is that cotangent, just like tangent, you know how tangent is tangent x equals sine x over cosine x. Cotangent is cotangent x is cosine x over sine x. It's the opposite. So right here, these things, and this one will become cosine of x minus pi over 2 over sine x minus pi over 2. This one becomes cosine x minus pi over 4 sine x minus pi over 4. This one becomes cosine x plus pi over 4 over sine of x plus pi over 4. All you gotta do is focus in the denominator. Focus in the denominator. Okay, the thing is, a vertical asymptotes happened in the denominator. I need to find which of these denominators will give me 0. Which of these denominators will give me 0 when I plug in 3 pi over 4. Okay, if I plug in 3 pi over 4 to this one, I'm going to get sine of 3 pi over 4 minus pi over 4. This becomes sine of 2 pi over 4. 2 pi over 4 simplifies to pi over 2. Pi over 2. Pi over 2, pi over 2, pi over 2. This one is pi over 2. Remember, this one is pi over 2. And the coordinates at pi over 2 are 0, 1. So at pi over 2, sine is 1. This thing gives me 1. Unfortunately, then, C is not the right answer. So C is not it. Let's see D. It'll be sine of 3 pi over 4 plus pi over 4. This will become sine of pi, right? Because pi, it'll be pi, yeah. 4 pi over 4. It's going to be, so at pi, this one is pi, and the coordinate is negative 1 comma 0. Ooh, look at that. The sine value is 0. D is the right answer. We can of course try this one. It's going to be sine of 3 pi over 4 minus pi over 2. Let me rewrite this pi over 2 into 2 pi over 4. This will be sine at, this will simplify to become 3 pi minus 2 pi. That's just going to be pi over 4. And as you guys can see, at pi over 4 is actually right there. Is the one from the unit circle. We don't have that. Would be root 2 over 2. Okay, not that one. And this one would be sine, for the first one, it's actually just sine x. On the bottom will just be sine x. If x is 3 pi over 4, on the bottom I'm going to have sine of 3 pi over 4. And 3 pi over 4, it's just over here. And that's again root 2 over 2. D is the value for which the denominator will give me 0 when x is 3 pi over 4. Because that gives me sine of pi. And at pi, sine, the y value is 0. So D gives me vertical asymptote right there. 25, 26. The function r is given by r of x equals that whole thing on top in the xy plane. Which of the following is true about the holes in the graph of r? Okay, well, let's find the holes. Okay, let me get the function. Sorry, it's r of x. The function r of x, the whole thing in factor form. The whole thing in factor form. Two numbers that multiply to -2 and add up to -1 is x minus 2 and x plus 1. That's the factors on the top. And then in the denominator, I'm going to have x plus 1 times x plus 1 times x minus 2. All right. So these right here would have been my vertical asymptotes. All of these would have been, you guys could be like, oh, there's a vertical asymptote definitely at -1 because -1 makes this whole denominator 0. Sure, there's -1 repeats twice, but it makes nothing. For sure, a vertical asymptote, a very vertical asymptote. There's just one vertical asymptote at -1, right? And then right here, you're like, oh, a vertical asymptote at +2. But what's going to happen to the vertical asymptote at +2? It becomes a hole. I have a hole at x equals 2. Definitely. And then you guys look at this and you're like, oh my goodness, there's another hole at x equals -1, but the thing is, wait right here, wait right here, wait right here. You see this x plus 1? It's still there. The thing is, -1 can still make this denominator 0. That means this whole, which we thought it would have become a whole because one of those factors got, sure, it's a whole, but then at the same time, -1 makes that makes the denominator 0. So the thing is, at -1, we still have a vertical asymptote. Asymptote at -1, or at x equals -1. Okay, so the whole will be there because the x minus 2 completely got away from the denominator. Okay, and these values need to go away from the denominator for them to not be vertical asymptotes anymore. Okay, the x plus 1, sure, one of the x plus 1 in the denominator got away, it went away, but there's still an x plus 1 in the denominator, which that x minus 1 can still make the denominator 0. Remember, vertical asymptotes are values of x that make the denominator equal to 0. Okay, so that -1 can still make this denominator equal to 0. Therefore, there's a vertical asymptote still at -1. And sure, you can say there's a hole at -1 as well, but if there's a hole on the same spot as the vertical asymptote, I mean, the vertical asymptote overtakes the hole. Okay, there's going to be no hole in the vertical asymptote because the vertical asymptote's already there. Okay, so this is it. There's a hole at 2 only. So this one is true. Holes at, okay, A and B are not right. Okay, because it's telling you that there's holes at -1 and 2. Okay, it's either this one, because the multiplicity of -1 in the denominator is greater. Yes, it's greater than the multiplicity of -1 in the, yeah, in the top you only have multiplicity of 1 for x plus 1. On the bottom you have multiplicity of 2 for x plus 1. Okay, wait, which one was I reading? The denominator is greater than multiplicity is greater than, and because the multiplicity of 2 in the numerator is equal to the multiplicity of 2 in the denominator. Yeah, the multiplicities of both x minus 2 is the same, so they do get cancelled out and they do become a whole. So C seems to be the right answer. Let's finish reading. Let's finish D as well, just to be sure. It says, because the multiplicity in the numerator is equal, okay, there you go. The multiplicity of -1 in the numerator is equal to the multiplicity of -1 in the denominator. No, the multiplicities are not the same. For -1, the multiplicities are not the same. The multiplicity on the bottom is bigger than the multiplicity on the top for -1. So C is the right answer. '27. Regression models, guys. I'm sorry, I'm gonna skip any regression models right now. There are the type of problems, guys, that I'm like, it's kind of like too complicated, too complex, or maybe just a lot of terminology that you have to know for some questions that to me is like, I'm maybe not going to spend a lot of time reviewing it. Sure, on the day of the test, study it, see it, take some time. If you find yourself already mastering all the other more common topics, sure, take some time to learn something like the regression models. Okay? If not, you can skip it. Let's read it. And by the way, question 28. Question 28 is this one. You got this thing. Remember we did this in class today. And it's going to be this one. Remember, this one is your A, and this one is your B. Okay, this one is A, this one is B, and you got to calculate A over B. What do you see? What do you get when you get A divided by B? You're going to get 2 over 4. And this thing is 1/2, which is less than 1. Okay, if x less than 1, remember, if this thing is less than 1, the graph was going to look something like, oh, and by the way, it's negative cosine, so it's going to be along the x-axis on the left side. So this thing is going to look actually something like this. So you're going to go through the origin. Sorry, my bad. It's going to go through here. No. Yeah, no. It goes. I forgot. It's the graph that has a little thing right here, and then it looks something. It's supposed to look something like this. Okay, let's see. It's better to see it first. Okay, it's gonna go. It's gonna go down through here. It's gonna come down. It's gonna go all the way across onto the other side. It's gonna go back up. It's gonna go back into here, go into the bottom, and finally meet right there. By the way, all of these start right here. Okay. So it's going to look something like this. The thing is, why this one kind of like only you see only this section of it is because this thing is restricted. Wait, if a and b are between 0 and 2 pi. A portion of the graph, okay, so you see a portion of the graph is this and this. Upon a coordinate system, which of the following are values for a and b? A and b. That's the bottom part. That would have to be the end part. Guys, I'm gonna skip this one. I don't know. We need to study this more. 28. Let's go back to 27. That's already 4 problems that I don't know. Maybe 3 problems that I don't know. Okay, it says a regression model S is constructed for a data set. The residuals from the regression are plotted and labeled. Based on the vertical axis of the residual plot, point A is located at 1.3 and point B is located at negative 2.5. Which of the following statements is true about the model and estimates produced by the model that corresponds to A and B? Guys, I would also skip this one as well. We need to review that. That's it for the review, guys. 28 and 27. I skipped those. Let's see, what else did I skip? What happened to my papers? What other question did I skip? 14. I also skipped 14. So that's 3 questions that I skipped. D was the answer for that one. And 23. By the way, 23 we can review it. The thing is, all it's asking is the function k of t. It can be written as p of c of t. It says which of the following statements is true about the function. Okay, right here, this function right here models a function of, it's a function of p. Okay, so it models electricity. Okay, this function gives you electricity. Okay, it's gonna be either c or d. Okay, because p is on the outside. P tells you what this function calculates. Okay, p is on the outside. So this function will calculate the temperature. The thing is, you can either plug in time to then calculate c. You can plug in time to then calculate Celsius, which will then calculate electricity. The question right here is K models electricity uses as a function of time. If we plug in time, we can get Celsius, and then we can get P, which is electricity. Or the last one, it says K models electricity uses as a function of temperature. The thing is, sure, if you plug in temperature in Celsius, you can also calculate the electricity. So right here is the function in terms of time, which can calculate Celsius and then electricity, or is this function a function in terms of Celsius, which we can also plug in and find P. That would be my. That's why I'm not clear to the answer for 23. Um, I would say the answer would be the temperature. I think it's in terms of Celsius. I don't think, sure, T helps, but I don't think it makes a big change, because ultimately you are doing the calculation in terms of the Celsius. Okay, sure, you use the time to get the Celsius, but it is the Celsius value that gives you the temperature. That's my logic going on through my head right now. That's why I think the solution will be D. That's it. Now we're in 30 minutes. Let me look in the answer. I'll look the answers and see what 23 is. We are done. Chill out, guys. Study a lot.